Hi there, this is Ian McTavish with Hoya Robotics Team 4152, and this is our Techno Girls mini-bot series of tutorials, and this is tutorial number 9, Gearbox Design. Again, we cannot do these kinds of things without our sponsors, so thank you very much to them. So the series of tutorials is based on building a little mini-bot so that we can develop all the skills that we need. We're doing this with a group of grades 5 to 10 girls, and they've really impressed me with how well they've been doing. So today we're going to design a gearbox for our robot. So just a quick summary: in tutorial 7 we picked our gears, and so these are the gears that we are going to be using, and I'm going to be using this information throughout the tutorial. So back into onShape, I'm just going to minimize, and just so you know, sites.google.com/tldsb.on.ca/technogirls is where you can find all of these tutorials. There's a slideshow which shows the detailed steps, and then these videos, which is where I actually walk through. So this is our slideshow, our CAD so far, and down at the bottom there's the plus sign, and on the plus sign we're going to create a new part studio. So with our part studio, here it is. I'm just going to right click and rename it to Gearbox Plate so I know what it is. And I am going to start off with some variables. So in my toolbar there is the variable tool right here, and it looks like an X in brackets. If you don't see it, there is a search tools, and if you do search, you can type in variable and you can find it. It explains what it does and everything. So that's our starting point. So here's our variable tool. First off, we want to use a number. I recommend that you always use a number, because if you use something like a length or an angle, then you can't do math on it because it's set as a length, and with a number you can do math on it. So the first variable that we're going to have is dp, and that is short for diametrical pitch, and that is the pitch of our gears. So if we decided that we wanted to use this but switch to 32 dp gears, then we could change the value of our variable. So click the green check mark, and over here we now have a variable that is 20, and that's great. We're going to move on, and we're going to add a few more variables. So keep clicking that variable tool, select number, select your name. So G1 will represent gear 1, and gear 1 has 14 teeth, so I'm typing the number 14 and clicking the green check mark. So just take a moment to quickly enter in all of those numbers. So gear 2, G2 has 50, and the X and number, and G3 has 16 teeth, and G4 has 48 teeth. And by doing this, we can refer to the variable value and not have to remember the number. We've already got that number. I just realized this one is set to length, so I'm just going to change that to number. Nope, fix that up. So it just makes it a little bit easier. So I'm going to use the right plane and sketch. You could use the right or the front. It really doesn't matter. So now that I'm in here, remember, anytime you're in a part studio, you need to click the letter N on your keyboard to normalize the view. That will allow you to get it as if you're head on. So we're going to start with some construction circles. And so when we're doing a construction circle, if you click the circle tool and click this tool, this is the construction tool. And the reason we want to do this is we want to lay out our gearbox and make sure that everything's going to fit, but we don't want to make holes with these. These are just to make sure that the gear teeth will actually engage. So I'm going to click on the center, and that will set the center of the circle, and I'm going to click on the outside, and I'm just going to hit escape. And the reason I'm hitting escape is because it makes it sometimes the values for my variable names are the same as a keyboard shortcut. So if I click the dimension tool and then click the circle, now I can type in the value. So I'm going to click G1, and you can see when I start typing the letters, the possible variables pop up. G1 divided by dp. So the number sign indicates that it's a variable. And so I've got gear 1 divided by dp, so that will give me the number of teeth divided by the diametrical pitch. And that value, which is 0.7, is the diametrical pitch. So if I have another circle touching this, then the teeth, if they're both 20 dp gears, the teeth will actually engage. So it's a really handy way to do this. So the next thing that I'm going to do is I'm going to add G2. So again, it's the circle tool and construction. So I'm going to just click over here in the top left to start my center. And you'll notice that I'm waiting until my circles are touching, and I get orange and I get the tangent constraint kicking in. So I'm going to click. So that means, let me just turn those tools off. And if you look, I can now drag this circle around. And whenever I drag it somewhere, it will snap back, and it's always going to be touching that other circle. So I know now that if I have a 14-tooth gear centered on this and a 50-tooth gear centered on this, the teeth will be touching. I do have to set the diameter. So this is gear 2. So I'm going to type G2. There's G2 divided by dp, and there we go. As I mentioned before, this is really handy. I'm just going to demonstrate. So right now it's a 20-tooth gear, or a 50-tooth gear. If I went in here and changed that to a different number of teeth gear, you can see it automatically resizes the circle based on that. So I better just keep that as 50. So that's the handy thing, is that I can swap out gear ratios really easy, and I don't have to reset the values for the circles. They automatically adjust. Now, a couple things that I'm going to do. One of the things, I'm just going to quickly pull up the slideshow for a quick moment and just pop over to... Okay, so we're going to start adding holes. So, for example, our first gear has a 0.8-inch diameter for the teeth. So our motor the shaft is going to go through the hole where that first gear is, because this is attached to the motor shaft. So we're going to make this hole 1 inch because we want to be able to easily get it in. We don't want the teeth rubbing on the hole. So we're going to make it a little bit bigger. So I'm just going to go back into here, and I'm going to create a new circle. And this time it's not a construction circle because I'm going to want a hole. It's centered there. I'm going to click and move, and I'm going to type the value of 1. So now I have a hole that we will be using later on for the motor shaft to go in. Now the other aspect that I need to keep in mind is that I'm going to need mounting holes. So this is the drawing from Vex Robotics, and you can see there's 2 mounting holes. They're on a 2-inch circle, and the holes are designed for 1032-inch screws. So I'm going to add some mounting holes to this, and I'm going to do that. If you just watch, I'm going to create a line, and it's going to be construction because I don't want to cut this out. I'm just moving over down here for now. And I'm just creating a line that's at an angle of slightly 2 inches in length. And I'm being very careful. Nothing is in orange. So if you had something in orange, that would constrain it. So you'd get errors later on. So it's something to keep in mind as you're doing this. Now, I'm going to add my circles right now to the end. So if I center a circle right here, this circle, 1364, 13/64. And the reason I'm doing that is the mini sim motor takes a 1032-inch screw. So I have just done some tests and found our 1364 screw bit works perfectly for that. So that's the way I'm going to do it. So now that I've got that set up with my holes, I'm going to use the midpoint tool, and I'm going to select the line and the center of the circle, and that will constrain my circle so that it's midpoint. If you don't see all the tools, you probably will see one of the first ones with a little drop down, and it's because your screen resolution, so you need to look for that. Again, if you're not sure, you could search for midpoint and you would be able to find it that way. So I've got my circle, I've got my mounting lines. I'm going to now set the angle that this line is at. So I'm going to use my dimension tool, and I'm going to click on the horizontal axes. Click there once and click on this line once, and you can see I can now enter in the angle. And I'm going to pick a 45-degree angle. And the reason that I'm doing this is because I want to have this wheel or this gear down a little bit, just to position things nicely. And with this, there's no reason I picked 45 other than it's an easy value to remember. So now I'm going to click my dimension tool, and I'm going to specify where this center of the big gear, gear 2, is in relation to the horizontal axis. So I'm going to click that, and I was playing around with this and I figured 0.75 inches is a nice value. So there we go, I've got this. You can modify these once you've got things designed. You can play with those values if you want to change them around. So I'm going to now add G3. So gear 3, again, it's a circle and a construction line. Gear 3 is going to be on the same shaft as gear 2. And so I'm going to use the center of gear 2 as my starting point, and click and just hit escape. And now I can click the dimension tool, click the circle, and now I can type in my dimensions. So G3 divided by dp, those are my variables, and that will set a 0.8 inch diametrical pitch circle there. So that works well. And I just want to quickly jump back to the slideshow. Got a few slides to skip through. So basically, the shaft that G2 and G3 are on, we're going to need a bearing. And we're going to use these 3/8 inch round bearings. The reason is we get them in the kit of parts whenever we buy, and we get an AndyMark drivetrain from the kit of parts. So it's a good bearing to use. And if you're looking at the AndyMark website, you can see they list the inner diameter, which is 0.375 inches, and the outer diameter, which is 0.875 inches. You'll notice that I'm going to increase that value by 0.01. So anytime where I have something that is going to fit within a hole, I want to make sure to add a little bit of space to it, because if it's the same value, it's not going to fit very well. I'm not doing that with my screw holes like the 1364 because I've already determined that that's a perfect size. So I'm going to add 2 circles now, and whoops, I'm just going to escape and go back here. So circle number 1 is going to be for the inner diameter, which is 0.385, and circle number 2, so these are all centered, is going to be the outer diameter, which is 0.885. And again, I could use variables for this, so that way I could modify my variable values and stuff, but that seems to work pretty well. And you can see this sketch is starting to get fairly busy. That's why I'm kind of adding these as I go. So G4 is my last gear. Again, it's a circle and it's a construction. So I'm going to click up in some space here, and I'm going to make sure that it gets orange with G3, which is the smaller of those 2 circles right there. And I'm going to click and just hit escape, and the dimension tool to now set the diameter. So this is G4 divided by dp, and enter. So I now have that. I've got the dimension for it, and I'm going to specify the distance from the center to the horizontal axes, and I'm just going to pick 2 inches. That way there's a bit of a gap between the gear and the screw, so that way things aren't colliding with each other. And that's one of the reasons that we do stuff like that. So I've got that set up. Again, I'm going to use the same type of bearing on there. So I'm going to click my circle tool, and my first circle is 0.385 inches in diameter. I'm just going to move so I can see this a bit better. And the second circle is 0.885 inches in diameter. So I've got spots for those circles. Now, we are going to mount this. So, just want to explain why. So here is the Minisim gearbox, and you can see that the diameter of it is 2.52 inches. So we don't want to have our gearbox mounted on the square tubing, and then we're stuck because the motor is actually inside the square tubing. That wouldn't work. So we've got to make sure that we adjust for our mounting holes, that we adjust that height. So we are going to do that right now. And in here, I'm just going to zoom out. So scroll wheel allows you to zoom. Holding the scroll wheel on your mouse and moving allows you to position. So I'm going to create a line. So select the line tool. And I'm just going to go down here and I'm going to click start. Now, you'll notice now that I've got the line vertical, I can see there's a little orange dotted line in there and the vertical constraint. So that's perfect because I want this to be vertical. And it's going to be 0.25 inches in length. And so what I'm doing is I'm going to create a slot. Instead of a hole for the screw, I'm going to give it a slot. And that allows me to do slight adjustments in the positioning. So I'm going to set the distance from the axes. So there's the dimension tool. And what I'm going to do is click the horizontal axis and the top of this line. And what I'm going to do is I'm going to click and I'm going to type in 2.52. So that's the diameter of the Minisim. So half of that is the radius. That's what I need to deal with. And then plus 3/8 of an inch. And that's because I want to pop this down. So the center of my slot will be at the perfect location, but I've got a little bit of leeway then in terms of being able to move this up and down to kind of position things. So that's set up. There's my line. In this set of tools, you can see there's a slot tool. And again, use the search if you don't see it. And if your resolution is such that the toolbar is reduced, the first one will have a drop down with all the tools in this section. So there's the slot tool. I'm going to click the slot tool and I'm going to click the line. And that will now create a slot. And if I click over to the dimensions, right now the default is 3/4. I'm going to change it to 13/64. Oops, I messed up. Let me just redo that. Slot tool, click the slot, and then click on the outside. So this measurement up here is the measurement that I'm looking for. So that default's a 1/2 inch, my mistake. So 13/64 is now the diameter of my slot. So it's the perfect size for my machine screw, but it's long, which will allow it to fit nicely. Now I'm just going to line this up. So I'm going to use a vertical constraint. And what I'm going to do is I'm going to click the center of this gear right here and click the center of my slot, just so that it's vertically constrained so they line up. Now, with my gearbox, I'm obviously going to need more slots. So if I use the line tool, notice that I can move over to the side and the horizontal constraint will force that point to be horizontally constrained. And I'm using a technique that I find really useful so that way I don't need to force the length at all. This point is horizontally constrained and this point is horizontally constrained. Do it on the other side so you can see. So I start and just move over, click, and now what I'm going to do is just move over to that point, and you can see I've got my dotted lines, so everything is constrained, so I don't need to worry about the measurement. They're perfectly lined up. And what I'm going to do is click the slot tool. So I'll click these two lines, and whoops, I'm forgetting to click those two lines, click to set the slot, and now I can change the measurement to 13/64. You'll notice, because of the way I constructed these, it went, oh, because you're creating both of these a slot, we're going to assume that they're equal. So it adds an equal constraint, which is handy, so that way I only need to type the size once. So there's little tricks that you can learn to make your life much easier. Now I'm going to, my hole pattern on my square tubing on the side is 1 inch apart. So I am clicking the center of these and changing it so that it's 1 inch apart, center of that 1 inch apart. So last thing is I've got all my holes, but I don't have any material to make the hole from. So I am just going to click the rectangle tool, and I'm going to start on this corner and go down to this corner. So that will give me my rectangle. It's good practice to always constrain things, so I am specifying with my points. So that point to there should be 0.375 so that it's lined up with the bottom of the square tubing, and I know that because I just did the math. The center of this to there, I'm going to set that to be 1.5 inches, just so it's a little bit bigger than what the gear is going to be, but not too much. And this line to that point, again, 1.5, just so that I've got a little bit of space. And I just need this distance, so I'm just going to go from that point to there and 0.5. So now I've got it fully constrained. Don't worry. This is just our first gearbox, so we're dealing with the rectangle. We will actually cut out some stuff later on in another tutorial. So I'm going to save my sketch. I always try to name things so it's easy to find them again. Check mark, and I've got my sketch. Now, the next part is a little tricky, so pay attention to what's going on here. So I'm going to click the extrude, and I'm going to click the shape. Now what I'm doing is I'm also clicking these two circles here, so that one and that one. So these are the bearings, and I'm also going to click this arrow. So if you just look at it from the side, you can see that it's taking it from the sketch and moving that direction. And I'm going to set my depth to 1/8 of an inch. And what we're going to do is we're going to make this out of a 1/4 inch material. But I'm going to show you why we're doing it this way in a moment. So just click the green check mark, and we've got this. Now I am going to turn on my sketch again so that I can see what I'm doing. And I'm going to add a second extrude. So this second extrude, I'm going to select the gearbox, and you'll see that these circles, I'm going to leave them as is, and I'm going to select 1/8. So this time, the arrow is pointing this direction. And what we've got here is 1/4 inch material is what we're going to use to make this, and this is going to cut 1/8 of an inch deep so that those circles, and the reason for this is how is the bearing going to stay in place? This way the bearing will be pushed against this. It's got nowhere to go. So you always have to think about how are things going to hold together so that they don't fall out. So by doing this, my first extrusion extrudes that direction, and it fills in these holes, and then this one goes the other direction and it leaves those holes empty, so that way I've got a nice little inset. Everything will work, and we are now done our gearbox. We can rename it. So for my properties, I'm going to call it gearbox plate. And my part number, remember we use a naming convention, so TG, for yours you would use your initials. For our team robot, we would use our robot team number, 4152. The two next characters represent which particular robot we're working on. This is our mini bot. It's P because it's a part. Now 02, our drivetrain is our subassembly 1. Our gearbox is our subassembly 2, so that's why we're using that. And then dash 01, this is the first part in that. So I'm going to save that. And we're going to right-click and assign a material. And the material that we're going to use is a polycarbonate. And polycarbonate is also called Lexan. It's kind of like bulletproof glass. It's very strong. It's very easy to machine. And for this project, we're trying to learn different skills. So normally with the gearbox, I might use aluminum plate, but for this, I want you to learn how to carve polycarbonate. Anyways, hope that helps. Have a wonderful day.